question. So for number 5, it says, if the race course were 15 meters long, who would have won, the tortoise or the hare? So if we would have stopped at 15 meters, write down who you think would have won the race, because they're tied at 16 meters. We can see here at 16 meters they're tied. But what would have happened if they only had to race 15 meters? Who would have been our winner? So write down what you think there. Who said that? Oh, okay. We have a few Andrews and they get mixed up. All right. Okay. Which one?
I think it's gonna be the hare.
Okay. And why do you think that, Andrew?
Because at 16 they're the same, or at 4 seconds they're the same, but at 3 seconds it's just one above the tortoise.
Good. So they end up being tied after 16 meters, but if we go back to 3 seconds, notice who was winning? The hare was winning at that point. So he is ahead currently. And over the next 1 second, the hare catches him, and that's what happens here. But in the meantime, he would have been leading the whole time until they reach this time of 16, or at least the distance of 16, so that we would say the hare would have won if they had stopped before they got to the 16. 16 is when they matched up. If they had stopped a little bit earlier, then he would have held on to his lead. All right. All right, so now number 6. This is asking what is the domain and range of each function. So what we want is the actual function itself, not just your table. So the table stops at 10, but we want the actual function. So if we look at this quadratic equation, try to do these two. So let me graph this for you, the y equals x squared. And then you tell me what you think your domain and range was on this. We reviewed this a little bit yesterday. I think we needed that review. I think a lot of us were a little fuzzy on that. So if this is what y equals x squared looks like, tell me what you think the domain and range would be for that. Domains left and right, ranges are up and down.
The domain is negative infinity.
Hang on just a second, Gavin. Hold on, Gavin. I'll come to you in a second. Let's get some people writing some stuff down. Thank you, though. I got your email. You're good.
Oh, okay, you got the email.
Yeah, thanks for letting me know. Mr. Krubowitz, he informed me he had something going on. If you marked him tardy, please clear it.
Sorry, who is that?
Nick Charles.
Okay. Thank you. I'll change that up.
All right, thank you. Okay, hopefully we got this answer. Here's what this graph will now look like. So let's come down here. And then we'll go to Gavin here in a second. So for the domain for, definitely don't want that. So we were dealing with t squared. The graph looked like this. All right, Gavin, what'd you come up with, bud?
For the domain, I got negative infinity.
And infinities are always parentheses. So good. This will go left and right forever. All right, your range, Gavin?
I got 0, infinity.
And then definitely a parentheses around the infinity. Those will always have parentheses. And then what did you think for the 0, Gavin? Parentheses or a bracket?
The bracket.
Good. And why a bracket again? Could you refresh us?
It's not infinity.
Sort of. The reason we want to include this is look at this graph here. Do we actually hit a y value of 0 on our graph? Okay, and since we do, we're actually hitting that point. We have the point 0, 0 on our graph. So since we are hitting that point and it crosses there, that's why we want to include that. 0, 0 is a y value that this graph touches. Yeah, Cam?
So if we wanted to hit the 0, it would be a parenthesis.
Yeah, so if I gave you, was afraid he was going to do that. Say that again, Cam.
I think I remember last year we would like determine if the circle was colored or not, right? If
Solid
the
dot.
circle was open, it would be a,
Keep going.
yeah, that's what I remember from last year.
Good. That's good. So let me pull this up, and that's what I was just going to do when my computer jumped on me. So let's say I now drew this graph in like this, and our parabola comes here. I tell you there's an open dot here, and then it goes up. Now that that's an open dot, now we would want to go to our parentheses, and then that's when we would make this a parenthesis, or go to our 0 and make that a parentheses. But since this is solid on the point y, on the y value of 0, that means we're actually touching that point. We actually hit that point, and that's why we would want that one to be closed. All right? Okay, good. All right, next one. Sorry, that's the same one. So see if you can do the domain and range for the exponential function, which was t squared. And then again, I'll show you on the graph, so it's a better looking graph than what I would put on my computer with my pen. So this is now 2 raised to the power of x. Let me clear all this up. And that's what this is going to look like. So then write the domain and range for this one. All right, and let's see what we came up with here. I'm going to hope, so for this one here, here's kind of what the cheap graph looks like. This is our, why did I do that again? This is your exponential function, so 2 to the t. And then I would hope the domain we all got. So 2 to the t. This is roughly what our calculator had. So domain-wise, let's go. Michael, what'd you put for your domain there for this graph? I think Michael's just frozen on me unless he can stare really well. Oh, there he is.
Domain, I put negative infinity, infinity.
Good. So this definitely goes left forever, and even though it goes up very quickly, it's going to continue to move to the right forever. So we do go left and right forever. The range, we did discuss this a little bit yesterday. This is a little bit tricky. I'm going to assume we all say that goes up forever. That's pretty obvious that that graph is going to go up forever. What do you think for your range, Mike? What do you think for that beginning part?
I didn't get the range. I don't know.
Okay, and this is the tricky one. Cam, what do you think?
I think it's 0.
So he says 0. And then what?
Yeah.
Parentheses or a bracket, you think, Cam? All right, why do you think that, Cam?
Because it didn't hit the value of 0. It like kind of looked like it went like right above 0.
Good. So that here's the x value of 0. Your x-axis is the value of 0, and this thing just hugs it the whole time. It never touches it. If you remember yesterday, so if I go to the calculator again, so I'll show you these values in our table. So if we go to our table, although now I'm way huge, I did something else earlier today. If we move, let me do this faster. So if we move to 0, so let me start this off at 0. All right, so now watch as I go further and further left. We're going to get really, really, really close to 0. But does this column here, which are the y values on our graph, do these ever touch a y value of 0? No, they just start giving you really, really, really tiny scientific notation numbers because you're getting closer and closer to your 0. So that what Cam said is dead on in this case. We get really, 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 really close to 0, but since we don't ever touch it, that's why we've got to leave this open, and we do that by using a parentheses. Okay? Good. Okay, last thing. A lot of good review here of what you did last year between yesterday and today. So now it says, using your graphing calculator. I've already shown you what these look like, so let's do the first one. So let's just sketch this out. So this is that first graph. And then remember how your teachers would make you describe the features of each? You would have used words like maximum value, minimum value, where are we increasing, where are we decreasing, domain, range, all that good stuff. That's what we want to do here. So our domain and range, we already know for this one. We've already answered it. So let's put that as negative infinity to infinity. And then our range we know is a bracket 0 to infinity. So here are some other features that you would have talked about last year that we want to now recall. Your teacher would have asked you to figure out what's your maximum value, what's a minimum value. Sometimes we don't have those, sometimes we do. They would have asked you, where do we increase? And you would write that in interval notation as well, parentheses and brackets. And where do we decrease? So see if you can tell me what you think for those. I think those are the main things you would have talked about with features last year. Although maybe we could do this one and then I leave the other one for you to try since we're kind of reviewing. Let's do that. Okay, let's do this one together. We'll walk through these next 4 things and then you can try that next one. I'll give you a minute or two to write those down. Let's do the minimum value first. If we look at this graph, the minimum value was always your y coordinate. So if we look at that graph, what is the, you would just ask yourself, what is the absolute smallest y value that this graph would ever hit? And you've kind of already thought that out by defining your range. If you look at your range, you've already talked about what your smallest y value would be. Our smallest y value would be the lowest point on the graph, and that would be 0. So you would say your absolute minimum value is the y value of 0. This one is asking you what's the absolute largest y value we would hit. So the biggest y value that we would ever hit. So if we look at this one, do we agree that this thing is just going to increase forever and ever and ever? So that's when you would have said something along the lines, depending on how your teacher wrote it, there isn't any. There's none. There is no largest y value because we just get larger and larger and larger and larger. Okay? Increasing. When we look at this graph, this is as we move left to right, we want to talk about, is our graph going up or down? And if we go up, it's increasing. If it goes down, it's decreasing. So initially, as we look at our graph here, what we would be doing, so let me kind of trace in the initial one, make it a little smaller, is what are we doing initially over here? Going up or down? Down. So we are decreasing until we hit this point right here. So we're going to be decreasing. So let's start with decreasing until we hit the y value of 0. Wouldn't we be decreasing everywhere over here this entire time? So and these are always, and my students would always have this issue, these are always your x values. So we decrease from a negative infinity all the way over here. We're always decreasing until we hit the x value of 0. We're decreasing. All right, if I ask you for where you're increasing, once we hit this value, would we agree that this graph is now increasing after this point? Yeah, so our increase, we would start at 0, and then we increase the rest of the way. The further and further right we go, you're going to continue to increase. All right, and then that's always your x values for the increasing and decreasing intervals. All right, so now your test is to take the other graph that I had shown you that looked like this, the exponential graph. We already know your domain. We said we go left forever and right forever, so negative infinity to infinity. We know our range. We never touch 0, so we're going to open it with the parentheses. We get really, 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 really close, but we never touch it. And we go up forever. So the 4 things now, and I'll give you 2 minutes. Determine if there's a min value, and if there is, tell me what it is. And if there is a max value, tell me what it is. And again, it's possible you don't have any, or one or the other. And then give me an interval where that graph is increasing, if there is one, and an interval where that graph is decreasing, if there is one. All right, let's see if you remember this. All right, I'll give you another 15 seconds here. As a little hint, you should get a lot of nones here, like writing there isn't one, we don't have, it doesn't happen, something along those lines, however you wanted to express that. You should get a number of them, of these 4. Okay, let's do this. I'm going to come back to the min value. I'm going to do that one last. Let's go to the maximum value, because it's something that we've already talked about here in the last 5 minutes. If I ask you what your maximum value is, in terms of what's the highest value that this graph will hit, what do we think our maximum value would be? Nora? Good, there isn't one. So something to that effect. I'll put none. You can put there isn't a maximum value, something along those lines. If this graph is going to continue to climb forever and ever, we don't ever have an actual largest value. It just gets bigger and bigger. Okay, increasing. So if we look at this graph, if I were to kind of shade this, does our graph increase? So if I do this, am I increasing right now? Okay, you agree with that? Anybody have the interval for where we are increasing? As we go from left to right, what do we think in terms of when we are increasing? Cam?
Bracket 0, comma infinity.
So you're saying we're going to increase forever, right, to this point? And then that started right here. So we're only increasing in here?
No, you're increasing the whole time.
Oh, then why are you starting with a 0 there, Cam? How do we say we're increasing?
Would it be negative? Would it be negative infinity?
That's it. Yeah, we're increasing the whole time. So if we look at that, he couldn't have said it better. This graph increases the entire time. So that's a negative infinity to infinity. We are always going up as we move left to right, which makes the next one really easy, right? Like if we're always increasing, like Cam said, if we ask for an interval where this graph goes down, there isn't any. There is none. It just always goes up. All right, so now our minimum value. Let me go back to our calculator. We'll cheat a little bit. So notice again how our numbers are getting smaller, 0.25, 0.125, smaller, smaller, smaller. Now we're going scientific notation even smaller. Do we ever actually hit like the value of 0? No, but are we continuing to get, we all know how scientific notation looks like. You've been dealing with that for a long time. Notice how we're getting to the negative 10th power. Eventually we'll go to the negative 11th. That number continues to get smaller and smaller and smaller and smaller. It's getting closer and closer and closer to 0. But the fact that it never actually touches 0, and if you got this, good on you, because that's not easy. You would say there is no minimum value here. Okay, and if you got that, you understood that, that's really good. All right, we never touch that x-axis. We just get smaller and smaller and smaller. Okay? All right, I feel like I'm teaching Math 1 again with all this stuff. All that you would have seen before, again, we're just recalling all of this. All right, the last thing we're going to do, and then this is ultimately going to be your homework. I'm going to leave most of this down here for you. I do want to see if we remember when it says identify which of these are functions. We added that to our little notes yesterday at the very beginning. And if it is not, you're going to explain why. We talked about this with our vertical line test. This is a vertical line test. Let's see if you remember how we did this when you were given just a set of points. Recall, one x value can be paired with one and only one y value. And if this set of points satisfies that, then we're good. And if it doesn't, then you would say it's not a function. So look at that and see what you think. See if you remember these. Okay, anybody think this is a yes or a no? And I'd like to explain. Bisher, go ahead.
I think it's not a function because it crosses 2 twice.
The x value of 2?
Yeah.
Good. So let's go to this point here. Oops, that did not change over. So what he says when it crosses 2 twice, what he's referring to is this point here and this point here. Every x can be paired with only one y. So this x value of 2 is paired with a negative 1. So over here, when the x value of 2 also gets paired with a 5, then that tells us it's not a function. All right, basically the 2 is hanging out with the negative 1. They're dating. But then the 2 cheats on the negative 1 with a 5, and then that's bad. Okay, so when that happens, it's not a function. If it asks you to explain why, what Bisher said, pretty good. And just because x equals 2, it's paired with negative 1 and 5. And because of that, that's bad. Okay. Other than that, I think we can do all of these. Vertical line test in 2, vertical line test in 3. Number 4 is similar to number 1. It's just a different way of giving you a set of points. So you're just going to look to see, are there any x values that get assigned to multiple y values? Actually, do number 4. Let's see if you can do that one. And then I will set you free for the weekend a little early. All right, what do we think? Yes or no? Is this a function or not? See some head shaking, no. A lot of head shake. Some are shaking yes. Vicky says yes. All right, I'm seeing some yeses and some no. So I drew this graph real quick. So if we look at number one, so revisit number one real fast. If we deal the vertical line test here, so all I did in number one is I plotted the 0.21 and I plotted or 2 negative 1 and the 0.25. So when I draw a vertical line through here, see how this one touches both of those points at the same time? That's bad. That's why it doesn't pass the vertical line test. That's another way we could say that this is a no, which we've already established by looking to see that x is paired with more than one y. So it would fail the vertical line test. So now let's plot these points. When x is a negative 12, my y value is 25. So I'm going to plot that point. When x is a negative 8, I'm going to plot the same exact y value of 25. If the negative 6 gets a value of 25, it's here, and then a negative 4 has a y value of 25 as well. So even though all of these are repeating, right, all the y's are repeating, if I start drawing vertical lines in here, would this be okay? Would this pass the vertical line test? Yeah, so now a lot of people are starting to shake their heads yes. Okay, so this is in fact a function. So the x's cannot get paired with more than one y, but the y's can be paired with more than one x. All right, and that's kind of deliberately done in number 4 to make sure we're clear on that. All right. So with that then, this is your homework. You've already got 2 of them done. You're just going to do this page. This is the ready, set, goes, 1 through 10. And then it is online right now. Don't look at my email. Underneath your assignments. And it'll just say the ready, set, go 1.5. Whatever pulls up. Yeah, right here. Okay, so you have until Monday night, midnight again, to get that done. If you have any questions, let me know on Monday. Keep in mind, Monday we're going to do a little reviewing of all of this. So some similar things we're going to be talking about. Tuesday will be your first kind of test, and really all that means is probably going to be more problems. It'll cover everything we've done, and you'll probably be given the whole 35 minutes versus just, you know, the short 15, 20 minutes that I've given you on the first couple of quizzes. All right. Okay, we've made it through 3 weeks. All right, we're getting there, slowly but surely. Okay, have a good weekend, and we will see you guys on Monday. All right, take care. See you guys.
Have a good weekend, everybody.
How do I close that out? Okay.
I didn't know if you talked to them before I